We're talking about nothing about but planets and comets and moons and things like that. What does it all mean? In other words, does it tell us some of our story? The answer is, near as we can tell, every time we ask a question, we discover the following. Everything in our solar system appeared about 4.6 billion years ago. Everything. We track back orbits, we track back comets, we track back, pick up rocks off the moon, we pick up rocks on the Earth. We take chunks, we had a Stardust mission come by and scoop out chunks of the ice in the back of the comet. The number keeps repeating. How long ago since the moon left us? 4.5 billion years ago. You know, the number keeps reappearing. So the question is, what happened 4.6, 4.5 billion years? Now, we're going to talk about what's called the dust cloud theory. This is the most common theory about how our solar system formed because of observations I've already told you about, so you'll understand this. So we have the sun sitting in the middle, and we have the planets. We have Mercury, which is going this way in a circle around. We have Venus going a circle this way around. Whoops, drawing that terribly, I apologize. We have the Earth going the same direction. We have every one of the I'm doing Mars. Mars goes around. Every one of the asteroids goes around the same direction. Jupiter, same direction. Saturn, same direction. We've got Uranus, same direction. We've got Neptune, same direction. All of them in the ecliptic, all of them are in the same disk. If you were to look at it from above, they're all traveling in the same disk. Most of the comets, most of the dwarf planets, all of them going in the same direction in a stable orbit. That's a smidge suspicious, isn't it? Why would everything go in the same direction? What is it about this direction in the same thing? Now, again, you can say, oh, well, the Oort cloud's different. Okay, fine. More interesting, also along the same lines, we have Mercury spins this way. Actually, let's talk about Mercury spin in a second. I need an eraser. Okay. Mercury actually spins this way. If I could draw an arrow, that would be great. Mercury spins this way. Earth spins this way. Mars spins this way. Jupiter spins this way. Saturn spins this way. I skipped one somehow. Mars, Saturn. Jupiter, that's Jupiter. Saturn. Uranus spins this way. And then Neptune spins this way. Why are they all spinning that way? Oh, and Venus kind of doesn't spin at all. But if it does, it spins slightly this way, but ever so slightly. So Venus really doesn't match this pattern, nor does Uranus. Neither one of them. I'm not going to lie to you and say they do that. Also, by the way, the fastest spinning is Jupiter, the biggest planet. The slowest spinning is Mercury. Mercury. So Jupiter's the fastest, biggest, smallest, and generally speaking, goes from biggest to smallest, fastest, slower. The one exception is Mars, a little out of whack, and obviously Venus is completely out of whack. So what's going on? What is the argument for why this would be? Well, we know angular momentum, don't we? If this thing is all spinning this direction, it has to have always been spinning that direction unless there's an outside force. Since it's unlikely there's an outside force, we believe the solar system was initially spinning in this direction. So we can say it was spinning in this direction. All right. So why are there planets? What happened 4.5, 4.6 billion years ago? What happened as this thing was going along? Well, and why is everything in the ecliptic? Why is everything this nice thin layer? Well, what happened, we think, is this. There may have been a ball of dust. And this ball of dust may have been spinning this way. And that ball of dust, as it spins this way, gravity is going to pull it down to the same ecliptic. So it becomes a disk of dust spinning in that direction. That disk of dust, as you picture it from above, would start to have bigger chunks. Bigger chunks would attract more because of gravity, and they would start to become planets cutting out chunks of the dust, leaving a vacuum behind them, sweeping out the space around them. Obviously, the bigger there had been a bigger concentration, that's our sun. They might think, aha, but Jupiter's bigger and it's way the heck out here. How does that happen? Well, Jupiter actually takes up a huge space around it, sucks up a lot of space around it. And maybe even why the asteroids have fell apart, the asteroid belt, whatever the planet was, the asteroid belt, it fell apart. Jupiter may have been pulling on it to try to suck it in and didn't quite pull it off. So why does this explain this turning? Well, think about it this way. You're a planet, you're just got your couple rocks together, you're starting to glue together, and you're in a great big pile of debris that is roughly traveling in a nice stable orbit around the sun. By the way, if you're not in a stable orbit, it's been going on for more than 4.6 billion years. You either hit the sun or you left a long time ago. 4.6 billion is a long time for the riffraff to get out of here. If you're not in a near stable orbit, you're in the sun, you're out of here. So what happens here? Well, we remember that v squared, remember Chase's law, gm over r, for all orbits that are stable, right? This r, if the r goes up, the v has to go down because it's on the bottom, correct? So if the r goes up, it means the v has to go down. The bigger the radius, the slower these are. So these guys out here are traveling slower than these guys out here, which are going faster. So what happens when I suck them into my rock? This thing's going to curl in and hit me. This thing's going to curl and hit this way, right? Now, this one's traveling faster, so in general, it's going to cause a spin this way because it's getting hit harder. That's why the planets all spin that way. He said all. Mr. Resney, Venus doesn't spin that way, at least not very much. Answer to your question is, I have no idea why Venus does that. Honestly, Venus doesn't make sense. Venus is fighting with us. Venus may have run into another rock. Who knows right now? Venus is still a vague question. But Uranus is much more interesting because it's rolling on its side. It's not even going the right direction. How did that happen? Well, here's where you Pluto enthusiasts get to have a fun-filled parade. Because Pluto got an interesting orbit. Pluto, which, by the way, does not sit in a pancake disk, actually goes up and down. The closest it gets to the sun is exactly Uranus's orbit. So it's got an elliptical orbit that's bigger than Uranus. In fact, it's bigger than Neptune. Neptune goes through it. It goes way the heck out in deep space and then comes back in. And when it comes back in, it just barely touches Uranus. Now remember, elliptical orbits are formed when you have a nice stable round orbit and you get an additional amount of energy that kicks you out into an elliptical orbit. Okay? Now for most of the comets, what's happening is these comets are sitting out in space, they get stopped, and so they get stopped into an elliptical orbit. So it'll be a nice round big orbit. They get stopped into a littler orbit. But it is interesting, in fact, very fascinating, that Pluto is sitting right there exactly in Uranus's orbit, our planet, which is the biggest question mark of all. Why is it rolling on its side, not obeying the laws that it's supposed to follow? Why is the moons, by the way, if you look at the moons, all the moons go in nice little patterns around these planets. It's all pretty nice, right on the ecliptic. Our moon is basically 2 degrees on average off the ecliptic. I mean, it's basically sitting in the same plane as all the planets. Uranus's moons are like, in fact, look, we've actually done some measurements to discuss. We think actually these things should collide in 4.6 billion years. And why is that important? Because we think most of the solid matter started to congeal, started to collect at about 4.6 billion years ago. And so therefore, how did this happen? And the answer to the question appears to be our friend Pluto. Something happened. Another object came sailing through, or Pluto itself came sailing through. More likely it was not Pluto, because Pluto would have had to have a nice stable orbit and get blown into a bigger orbit. And so something large, something awful came into Uranus's orbit, was doing so it hit the moons without actually touching them with gravity that caused them to turn into little pool balls going every which way. It may have scraped or actually hit Uranus in general, or maybe got sucked into Uranus. Some people are arguing that's still true. There's some questions to that. It's hard to imagine how big it would have to be to make that happen. But regardless, it tipped Uranus's pretty nice orbit, which we'd be able to discuss today as being just like the other ones, tipped over that, shuffled all the moons, and then Pluto was kicked off with his buddy Chiron, and they went out into this more elliptical orbit. All right? And so, hence the dust cloud theory. Now, what's the posits of the dust cloud theory? That at some point the solar system was a ball of dust. That ball of dust slowly got pulled into a disk by gravity and the fact that it was spinning. The gravity and plus it was spinning caused it to slowly, the spinning that close together caused the bits of debris over. Now, by the way, I'm going to give you a hint for the future reference. 12.7 billion years is when we think this thing happened, when this dust cloud happened. Maybe 12.8. Some people are going out as far as 13 point something or other. Not my problem. I'll give you better numbers in a little bit. But the bottom line is this ball of dust was spinning. It went out into space. That ball of dust thinned out because it was both spinning and gravity was pulling it in. Then gravity started to congeal into actual planets. Those which were stable exist today. Those were not stable, slammed in the sun, slammed into each other, went away and left us alone. In fact, there must have been a lot of unstable sorts of bits of rock that gathered because look at the moon. 4 billion years ago, the moon, Mercury were getting clobbered. There was still a lot of debris out there. We were still congealing planets. Okay? And so herein lies our story. Here's the story of what we think happened with the solar system. It is not the only theory. There's the people that point at the planets and say the following, that it makes more sense that the sun spits out routinely chunks of planets. You'd be in the minority for that, but you should know the following. The sun spins in this direction, which means if it's kicked out a planet, it would definitely go this way. How it would come to a circular orbit, some other things are disturbing about such things. It's a theory, and it's an interesting one. It also explains why they say Jupiter has moons going around it that go in the same direction as the planet turns. So I won't share with you much on that theory because I don't believe it's the most common, but it is another way to get the same sort of thing. So how did we get here? We're just a ball of dust. All right, 4.6 billion years ago, we finally congealed enough to start forming rocks, and they must have been molten awful. It took 8 billion years or more to turn this dust cloud into a bunch of rocks, which are similar to the planets that we see today. All right.